Hello everyone. Today we're going to look at rational equations and practice solving them. So whenever we have a rational equation, that's an equation that contains a rational expression. And the process is to identify the domain, finding the variable in the bottom of the fraction, the denominator, finding the common denominator, and solving. Whenever we solve, we definitely need to make sure we check for any extraneous solutions. And you might see the word extra in there. And that means that it was an extra solution that doesn't work. So actually, you found it by multiplying both sides, but when you put it back or substitute it back into the original equation, it doesn't work. So remember, when we look at the domain, we're looking at rational expressions, and they usually have a denominator in the bottom of the fraction, and that's going to restrict the domain. So if x is in the bottom or the denominator, we know that x cannot equal 0. Okay, let's start with the first example. So for this one, we have x plus 4 in the bottom of the fraction. So what I'm going to do is have x plus 4 here, and I'm going to just make that equal to 2. And we need to make sure we multiply both sides by whatever is in the bottom or whatever is in the denominator. So I'm going to multiply both sides by x plus 4. So you'll notice on the left side, these two x plus 4s are going to cancel out, and we'll be left with 1. And on the right side, well, we could simplify that. We could distribute. So we get 2x plus 8. And from here, we just have to isolate x. So subtract 8 from both sides. And we have negative 7 equals 2x. Divide both sides by 2. So x equals negative 7 over 2. That's going to be our solution. And it's definitely going to be okay, because the only number that's going to be restricted in this equation is 4, right? So that's one number that x cannot equal. So if we're going to ask what's the domain, well, x cannot equal negative 4. Okay, 5 equals 1 over x minus 3. And remember, we want to multiply both sides by whatever's in the denominator of that rational expression, so x minus 3. So the x minus 3 is going to cancel out on the right side, and that will be left with 1. On the left side, well, we have to distribute the 5, so we get 5x minus 15 equals 1. Add 15 to both sides. You get 5x equals 16. Divide both sides by 5. So x equals 16 over 5. All right, and looking at this equation again, the one restriction was x could not equal 3. So that number is going to work. Let's look at the next example. So for this one, we see an equation, and you could probably notice that we have common factors. So x minus 5 times x minus 3 equals x squared minus 8x plus 15. So when we have rational equation and we want to solve it, we have to multiply each side by the common denominator. And so we just said the LCD was x minus 5, x minus 3. So I'm going to multiply both sides by x minus 5, x minus 3. So this whole thing here and the whole right side by the same denominator. So what you're going to notice is on the left side, we're going to have things cancel out. So if I have x minus 5, x minus 3 over x minus 5, I'll just be left with x minus 3. And if I multiply x minus 5 and x minus 3 with x minus 3, I'll be left with x minus 5. And then on this side, on the right side, if I multiply x minus 5 and x minus 3 with this, remember they're going to cancel each other out. They equal each other. So then I'll just be left with 2. Now we made our equation much easier to work with. So from here, I'm just going to combine like terms. So we have 2x minus 8 equals 2. Add 8 to both sides, so 2x equals 10. And divide, and we get x equals 5. But remember, there is a restriction in this problem, where we said that x minus 5 is in the denominator and x minus 3. So we know, I'm going to put this in red, that the domain was restricted. So the x could not equal 5, and it could not equal 3. Since we got x equals 5 as a solution, this will not work. This is what we would call an extraneous solution. So we solved the equation. We were able to find a value for x, but it actually didn't work because it was not included in the domain. So this whole equation will have no solution. We don't have any values for x that would make this true. Okay, let's look at the next example. All right, so here we have x minus 2 in the denominator. And I'm going to write on the side that the x cannot equal 2. We know that from the restriction in the domain. The LCD is x minus 2. So if I multiply the left and the right side by x minus 2, on the left side it'll cancel. So we have x minus 2 cancel, and we'll be left with 5x. And on the right side, distribute. So we'll have 7 times x minus 2 plus 10, because the x minus 2 will cancel in the denominator. Okay, let's just simplify this. So we have 5x equals 7x minus 14 plus 10. 5x equals 7x minus 4. Subtract 7x from both sides, and we'll be left with negative 2x equals negative 4. Divide both sides by negative 2, and we get x equals 2. But if you remember, at the top, we said that x cannot equal 2. So again, we have another extraneous solution and another equation with no solution. So we have an extraneous solution from solving, but it actually didn't work in our original solution. Now for the next example, we can see right away in the denominator that x cannot equal 3. So that will be the restriction on the domain. And then looking at both sides, well, we have to make sure we include the 4 for the LCD, so that's 4 times x minus 3. Now when we multiply both sides by 4 times x minus 3, we'll be able to have some things cancel out. So let's first look at the left side. So on the left side, the x minus 3 in the denominator and the numerator will cancel out, and we're left with 4 times 3, which is 12. On the right side, looking at one fraction at a time, the x minus 3 is going to cancel, and we'll be left with 4 times x. In the second fraction, I'm going to use a different color here, the 4's are going to cancel. So we'll be left with negative x times x minus 3. So just be careful with that one. So here we have x times x minus 3. Okay, the next step is to simplify. So we have 12 equals 4x. Distribute, we get negative x squared plus 3x. Now I'm going to move everything to the left side, so we add x squared. I'm going to combine these two, that's 7x. Subtract it from both sides, we get negative 7x plus 12 equals 0. Now we're looking for two numbers that add up to make 7, negative 7, and multiply to make 12. So that's x minus 3, when we factor, times x minus 4. So we know that x can equal 3 here, and x equals 4. But remember, we have to go back to the extraneous solutions, or the restrictions, to see the extraneous solution. So remember, we said x cannot equal 3. So that's one solution that will not work. The only solution left is x equals 4. So this does have a solution, but remember, it also has an extraneous solution. Now let's consider two of the word problems here. So the first one is looking at work. So work as in rate. You may remember rate from when we looked at distance. But I want to remind you we had distance equals rate times time. And the same thing can be said with work. Whatever we're doing, whether it's painting a wall, mowing a lawn, washing the dishes, it's going to be the rate times the time. So for this problem, Arthur and Cheyenne are painting a wall. And we want to see how long it will take Cheyenne to paint the wall if she was working alone. So I'm going to put both of their names here. So Cheyenne and Arthur. So they're painting a wall, so put one wall for both of them. So thinking of the time it takes them, well, it'll probably take, we'll say Cheyenne X amount of time. But remember, she works faster than Arthur. She's twice as fast, so it'll take Arthur 2 times that amount of time to paint one wall. So considering their rate, Cheyenne's rate will be 1 over X, the wall divided by the time. And Arthur's will be 1 over 2X. Okay, so in this problem we're given that together they paint the wall in 6 hours. So I'm going to put their rates here. So Cheyenne's rate is 1 over X, and Arthur's rate is 1 over 2X. And together they'll paint one wall in 6 hours. Right, so that's the rate, so 1 over 6. So looking at these two fractions, we're going to have to find an LCD. So we know that looking at the left side, we need an X and a 2X. And we definitely need that 6 in there. So the LCD will actually be 6 times X. So multiply this by 6 times X. So we'll get 6X over X plus 6X over 2X equals 6X over 6. Lots of 6's there. Okay, let's cancel some things out. The X's will cancel and we'll be left with 6. These X's will cancel and the 2 reduces to 3. These 6's will cancel. We'll just be left with X. So what does that mean? It means that the time for Cheyenne will be 9 hours. And if we're thinking about Arthur, he would take 18 hours. So you're looking for Cheyenne, so we'll just keep X equals 9. Okay, for the next problem, it's very similar. It's another rate problem. So for this one, we're looking at paddling upstream and downstream with the current and against the current. So I'm just going to put C is the current. If we read down here, we say it shows that Jake paddles at a rate at 5 miles per hour. Okay, so let's complete this table. So we're going to say with the current and then against the current. All right, so let's look at the distance. So I'll put D here. So with the current, Jake traveled 16 miles. Against the current, he only traveled 6 miles. Looking at the rate, we know that if he's paddling with the current, he's already going 5 miles per hour. So with the current, it'll be 5 plus the rate of the current. If he's going against the current, he's paddling 5, but the current is going against him. So it's minus. And so the time here will be 16 over 5 plus C and 6 over 5 minus C. Now let's consider what they say in here about the time. So they said even though he paddled upstream for an hour longer than the amount of time he paddled downstream, so he was paddling longer going with the current. So I have 16 over 5 plus c plus 1 equals 6 over 5 minus c. So let's multiply both sides by the common denominator, which will be 5 plus c times 5 minus c. Okay, so we're going to have to distribute that to both sides. But let me just write it out. Okay, so on the left side, we'll be left with 5c times 16, because the 5 plus c and the 5 plus c would cancel each other out. So we get 16 times 5 minus c. When we distribute this to the 1, though, we'll just have both of them. So 5 plus c, 5 minus c. On the right side, the 5 minus c and the 5 minus c will cancel each other out, and we'll be left with 6 times 5 plus c. When we distribute, we'll get 80 minus 16c, and when we combine this difference of squares, we'll get plus 25 minus c squared equals 30 plus 6c. So now let's just combine all like terms. So I'm going to actually add the c squared. So get c squared here. I'm going to subtract 80 and subtract 25, add 16c. So when I add 16c to 6c, I'll get 22c. And then when I put these together and subtract them from 30, I'll get negative 75. Okay, so now we're looking for two numbers that add to make 22 and multiply to make negative 75. So that factors into c plus 25 and c minus 3. I'll put the equals 0 over here on that right side. So now we can separate each of these, and so we have c equals negative 25 and c equals 3. Remember, our c is representing the current. So we really think about this word problem, we really can't use the negative current. Okay, so we have c equals, and we'll write 3 miles per hour. So this has to be the current for the problem. And the negative 25 was irrelevant or extraneous. So we'll put the speed of the river is 3 miles per hour. I hope this lesson was helpful, and we'll go over more examples together in class.